Hey everyone, welcome back to Sums of Anarchy, Let's Solve. This is part 2 of a series where we are solving the Edexcel higher tier non-calculator maths paper from 2021. We've already done the first 5 questions in part 1 of this video series, so if you missed that, check that out first, and we'll pop a link to the paper in the description below if you want to get that for yourself. Okay, let's jump straight in with question 6. Question 6. The diagram shows a prism. The cross-section of the prism is a right-angled triangle. The base of the triangle has length 5 centimetres, the prism has length 25 centimetres, and it has volume 750 centimetres cubed. It wants us to work out the height of the prism. Okay, so the information that we need to know here is how do you calculate the volume of the prism? Well, what you do is you work out the area of the cross-section, so that's this right-angled triangle here. The area of the cross-section multiplied by the length will give us the volume. So what is the area of a right-angled triangle? Well, the area of that triangle, let's just draw a little triangle here. We'll mark in the height and the base, which we know. The area is going to be half times the base, which is 5, times the height, which is what we're trying to find out. Okay, so if the volume of the prism is the area times the length, then what we've got is the area, which we just worked out, half times 5 times h, multiplied by the length, which is 25, and that gives us the volume, which we know is 750 centimetres cubed. So what we need to do, we've got an equation here, and we need to basically solve for h. So how are we going to do that? Well, first things first, if we're multiplying by 25 on one side, we can divide both sides by 25 and that takes care of that. So now we're left with 125 times 5 times h, because if we divide by 25 on the left hand side, it's going to cancel out that times by 25, is the same as 750 divided by 25. And 750 divided by 25 is 30. So now we've got a slightly simpler equation. Okay, let's do that again. So we've got 5 on this side, we're multiplying by 5. The opposite of multiplying by 5 is dividing by 5. So we can divide both sides of the equation by 5. What that's going to do on the left-hand side is get rid of it. And what that's going to do on the right-hand side is we're going to have 30 divided by 5, which is 6. So let's change that for a 6. Simpler again. Okay, one more thing to get rid of on the left-hand side, and that's the half. Now, half is the same as dividing by 2. So what's the opposite of dividing by 2? Multiplying by 2. So if we multiply both sides of the equation by 2, what's going to happen on the left-hand side is we're going to get rid of that half, leaving us just with a h. And if we multiply the right-hand side by 2, we've got 6 times 2, which is 12. So we have found out that our height of the triangle h is 12 centimetres. Okay, question 7. The diagram shows a cube with edges of length x centimetres and a sphere of radius 3 centimetres. The surface area of the cube is equal to the surface area of the sphere. Okay, so they've given us the surface area of the sphere here, or at least given us the formula for it. So the formula for the surface area of the sphere is 4 pi r squared, but we've been given the radius, that's what r stands for, the radius of the sphere is 3. So we can apply r equals 3 into this formula. What we'll end up is 4 pi times r squared, 3 times 3 is just 9. 4 pi times 9, that's going to be 36 pi. So the surface area of our sphere is 36 pi. Now we know that the surface area of the sphere is equal to the surface area of the cube. So now we just need to work out the surface area of the cube. How do we do that? Well, what we need to do is we need to work out the area of one side of the cube, one face of the cube, and then we need to multiply that by 6 because there are 6 faces. I can't mark that one. On a cube. Okay, so what is the area of one side of the cube? Well, it's just the area of a square with side x. So it's going to be x times x, which is x squared. But we said that we have 6 of them, so the total surface area of the cube is going to be equal to 6x squared. So that's one face, which is x squared, and 6 of those, 6x squared. So it tells us that the surface area of the cube is equal to the surface area of the sphere. That means that 6x squared equals 36 pi. but we want to show x equals the square root of k pi, where k is an integer. So firstly, if we want to try and get closer to that equation, we want to have an x on its own on the left-hand side. So let's set about getting rid of everything else. So right now, the x squared is multiplied by a 6. So just like in the previous question, the opposite of multiplying by 6 is dividing by a 6. So if we divide both sides of our equation by 6, on the left-hand side, we're just left with x squared, which was the plan. And on the right-hand side, we've got 36 pi divided by 6, which is just going to be 6 pi. Okay, we're looking better already, but we've got one more step to do. Our equation at the moment says x squared equals 6 pi, but we want to show what x equals. So all we have to do is take the square root. So x equals the square root of 6 pi. And now that does look suspiciously like the thing we were aiming for, where k is indeed an integer and it is the integer 6. Okay, question 8. Solve x squared equals 5x plus 24. All right, so we've got a quadratic equation. So the first thing I'm going to do is I'm going to move all of the terms onto the left-hand side of the equal sign. So the x squared is already there. Now, if I move that 5x to the other side, it's going to become a minus 5x. And if I move the 24 to the other side, it's going to become a minus 24. And that's going to now equal 0. So this is in a good form that I can solve it. So what I'm aiming to do is I'm aiming to get it in the form of 2 brackets equal to 0, and they should tell me something about x. And how I'm going to do this? Well, I like to use a cross method. So what I'm going to do is I'm going to do a cross here. Now, on the left-hand side, I want the 2 terms that can multiply together to give this first term the x squared. Nice and easy, it's going to be an x and an x. Now, on the right-hand side, I want 2 numbers that are going to multiply together to give minus 24. And there may be a few of them, so let's have a look. Because there's a second condition to that. I want them to multiply together to give minus 24, but I want them to add together to give minus 5. So let's see what the possibilities are. So 2 numbers that multiply to give minus 24. So we've got 1 and minus 24. We've got minus 1 and 24. We have 2 and minus 12. We have minus 2 and 12. We've got 3 and minus 8. We've got minus 3 and 8. And then we've got 4 and minus 6. And minus 4 and 6. And those are all of the numbers, all the pairs of numbers that will multiply to give minus 24. But which ones are going to add to give minus 5? Well, it's not going to be 1 and minus 24, no combination of 1 and 24. 2 and 12 doesn't look like we're going to get to anywhere close to 5, but the 3s and the 8s, we can make 5s out of 3s and 8s, but we need to make a minus 5. So let's have a look. 3 plus minus 8 does indeed equal minus 5. So there's our culprits, 3 and minus 8. So I'm going to put the 3 here and the minus 8 here. So now what I'm going to do is this makes my first bracket and this makes my second bracket. So we've got x plus 3, it's a plus because it was a positive 3 here. And in the second bracket, we've got x minus 8. Okay, let's clear up some of this down here now. Now I've got my 2 brackets, I can go about solving it. So if you've got 2 things that multiply together to give 0, at least one of them has to be 0. So either x plus 3 equals 0 or x minus 8 equals 0. If x plus 3 equals 0, then x has to be minus 3. And if x minus 8 equals 0, then x has to be 8. So our answer to solving this is x is minus 3 or 8. Okay, question 9a. Write down the value of 7 to the power of 0. Now, anything to the power of 0 equals 1. So 7 is no exception. 7 to the power of 0 equals 1. Now, this is drawing on our knowledge of the laws of powers or the laws of indices. And sometimes, particularly in exams, we can forget those laws. So let's have a look at how we could have generated something to remember. So we could start with something nice and easy, like, for example, 2 squared times 2 cubed. Okay, so we know that 2 squared is 2 times 2, and we know that 2 cubed is 2 times 2 times 2. So if I multiply 2 squared by 2 cubed, how many 2's do I have now? 1, 2, 3, 4, 5. So that is 2 to the power of 5. So what I've just generated here is one of the laws of indices that says that if I've got two numbers in the same base and I multiply them, what do I have to do? I have to add the powers. So 2 to the power of A times 2 to the power of B is 2 to the power of A plus B, because 2 plus 3 was 5. So there's one of the laws that I can generate. In the same way, I could work out that 2 cubed divided by 2 squared, so that would be 2 times 2 times 2 over 2 times 2. Now I can go back cancelling 2's, cancel those, What am I left with? 2. Or, which is the same as 2 to the power of 1, we just don't need to write the 1. So what I've worked out here is that 2 to the power of A divided by 2 to the power of B is 2 to the power of A minus B. Okay, so even if we forgot the rules, we can quite easily generate a couple of the rules. So now let's have a look how that would have helped us to work out 7 to the power of 0. Well, we know that, let's say, for example, we have 2 to the power of 3 divided by 2 to the power of 3. Now, we know from just our normal division rules that if we take something and divide by itself, we're going to get 1. So we know that 2 to the power of 3 divided by 2 to the power of 3 is going to be 1 because it's something divided by itself. But from the laws of indices that we've just managed to work out, we also know that 2 to the power of 3 divided by 2 to the power of 3 is going to be the same as 2 to the power of 3 minus 3, which is 2 to the power of 0. So now we've worked out that a number to the power of 0 is 1. So that's great in case we forget that any number to the power of 0 is 1. Okay, 9b. Find the value of 3 times 3 to the power of 6 times 3 to the power of minus 6. Well, we've just generated some laws of indices. We worked out that if we have numbers in the same base and we multiply them to various powers, all we have to do is write down that base and add up the powers. So 3, that's technically the same as 3 to the power of 1, times 3 to the power of 6 times 3 to the power of minus 6, using our rule of x to the power of a times x to the power of b is x to the power of a plus b, we're going to add all these powers. So the answer is going to be 3 to the power of 1 plus 6 is 7, 7 minus 6 is 1, 3 to the power of 1, which is just 3. Okay, 9c, find the value of 2 to the power of minus 4. Now, 2 to the power of minus 4 is the same as 1 over 2 to the power of 4. So when we have a negative power, it's the same as 1 over that number to its positive power. So 1 over 2 to the 4 is the same as 1 over 2 times 2 times 2 times 2. So 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the answer is 1 over 16. Okay, 9d. Find the value of 27 to the power of 1/3. Okay, so we've got fractional powers here. So what do they mean? Well, if we have any number to the power of a half, that means the square root of that number. If we have any number to the power of a third, that means the cubed root of that number. So here we've got 27 to the power of a third. So that is the cubed root of 27. So what we're looking for is a number, let's call it blob, times by itself, that gives 27. So a number cubed that will give 27. And that number is going to be 3, because 3 times 3 is 9, times another 3 is 27. So the cubed root of 27 is 3. Okay, question 10. The diagram shows a shape made from 6 identical squares. The total area of the shape is 5,406 centimetres squared. Find an estimate for the length of one side of each square. Give your answer correct to the nearest whole number. So it's telling us it wants us to estimate here. It doesn't want an exact answer. So the total area of this shape is going to be the sum of the areas of each of these squares. So let's say that the length of one side is x, then the area of one of these squares is going to be x squared. So the total area of this shape is going to be 6x squared, because if each area is x squared and there are 6 squares, it's going to be 6x squared. And it's told us that the total area is 5,406. I'm going to round that down to 5,400. So if I know that the total area is 5,400, roughly, then the area of each of these squares is going to be 5,400 divided by 6, which is 900. So the area of one of these squares is approximately 900. So now I know that the side times itself is going to be 900, then each side must be approximately 30. And that's the estimate of each side, because I haven't used the exact number. I've rounded it down to make the calculations slightly easier. And in part B, they want to know whether the answer to part A is an underestimate or an overestimate, and we have to give a reason for our answer. So let's have a look. Well, we rounded this area down to 5,400. So if we rounded down, then this is going to be an underestimate. The actual length of x is going to be slightly bigger. All right, let's take another break there. That's the end of part 2. In the next video, we will tackle the next 5 questions of this exam paper. In the meantime, let us know if you found this video helpful by hitting the thumbs up. If you have any questions at all, you can drop those in the comments and we'll do our best to get back to you. Subscribe to Sums of Anarchy for more maths tips and tricks, and we'll look forward to seeing you in the next one. See you later.